Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about dynamics of rigid bodies. At ang ating magiging topic for today guys is all about curvilinear motions. At meron akong inihandang tatlong problems para dito para makatulong sa ating maintindihan kung paano tayo mag-solve ng problems about curvilinear motion. At ito yung ating first problem guys. So in the problem, if the velocity of the particle is defined by 2t plus 1i plus 3j in feet per second, and its position vector at t equals 1 second is r equal to 4i plus 3j. Determine the path of the particle in terms of its x and y coordinate. So this problem has the given answer. So to guide us whether our solution is correct. So let us try to analyze the problem by identifying what are those given. So makita natin that in the problem we are given here the velocity that is 2t plus 1i plus tj. Kung mapapansin natin, yung ating velocity is expressed in terms of vectorial notation. So let us now try to take this so that we will be able to analyze it later on. Similarly, we also have here the position also expressed in vectorial form when t equals 1 second. And that is r equals 4i plus 3j. And so you have here our given. And so, in order for us to solve the problem, siguro mas mabuti kung i-analyze muna natin yung mga given. So, puntahan natin itong given na v equals 2t plus 1i and then plus tj in terms of x feet per second. So, in this given velocity, this element that is 2t plus 1 serves as our x component of the velocity. Kaya this may be treated to be our v sub x, which is equal to 2t plus 1. That is the velocity expressed in terms of time t. Similarly, this 3 is the y component of the velocity. And this can be written as a v sub y equal to 3 feet per second. Ganon din when we are analyzing this position vector r, which is given as 4i plus tj. It follows therefore that this form is the x component of the displacement at t equals 1 second. Hence, we can say that this is our s sub x, which is equal to 4. And that this component of the position vector 3 will serve as our y component of the displacement at t equals 1 second. And we may write it as s sub y equal to 3 feet. So that if after you have analyzed from here, masosolve natin yung problem, di ba? Kaya lamang mas maganda kung meron tayo muna maintindihan when we are analyzing the problem. So, and I would like to share it to you because this is very, very important in the analysis of the problem. And what is this? Sinasabi dito na, if x and y are the coordinates of the position of the particle at any time t, diba? Then the time required for the particle to move x distance is equal to the time required for the same particle to move y distance. So kung meron daw tayong position vector whose components are expressed in terms of x and y, sabi dito, yun daw time that the particle will be required to move the x distance is the same time that the particle will be moving the y distance. And that will be used later on in the analysis. Kaya puntahan natin muna itong x component of the motion. So, yung x component of the motion, tinutukoy ko dito yung v sub x. So, given kasi yung v sub x, which is equal to 2t plus 1. So, in here, meron tayong velocity expressed in terms of time t. Pero alam natin na itong v sub x actually is the rate of change of the displacement in the x direction with respect to time t, or written as to be d sub sx over dt. So from here, we would say that d sub sx will be equal to the product of v sub x multiplied by t, and that is v sub x multiplied by dt. So that if this v sub x, which is given to be 2t plus 1 will be substituted here, then our equation becomes d sub x equal to 2t plus 1 multiplied by dt. And so kung mapasin natin dito, meron tayo ngayong natawag na differential equation which can be solved if we will be integrating both sides. So if we're going to integrate both side equation, but of course considering the limits, the s sub x will start the limit from the given that it will start the limit at 4 when time equals 1, diba? To x when time is equal to t. So that the limit of the right hand side of the equation, for t will have 1 is to t. And so if we will be integrating, the left hand side would have a value equal to s sub x, which can be evaluated from 4 to x, while the right hand side will be equal to t squared plus t, evaluated from the lower limit of 1 to the upper limit of t. And that if this will be evaluated, then our equation becomes x minus 4 is equal to t squared plus t minus 2. And let this be our first equation. Similarly, we're going to consider analyzing the y component of the motion. What is our y component of the motion? We have the v sub y, which is equal to 3. Follows therefore that this is actually a constant. But again, alam naman natin yung v sub y, diba, is equal to the derivative of s sub y with respect to time t. And so from here, we say that the derivative of s sub y will be the product of v sub y multiplied by dt. But again, if d sub y will be substituted with its value of 3, therefore the equation becomes d sub s sub y equal to 3 multiplied by dt. And if we are going to evaluate again the limits of integration, with the lower limits to be at 3 when t equals 1, therefore the lower limits of s sub y will be 3 to that of the value y, and the limits of integration of t will be from 1 to t. That if this will be integrated, the left hand side would be equal to s sub y evaluated from 3 to y, while the right hand side will be equal to 3t evaluated from 1 to t. And that if the limits of integration shall be substituted, therefore our equation becomes y minus 3 will be equal to 3t minus 3, and which can be simplified further to be because 3 can cancel, so this can be simplified to be y equal to 3t, which when simplified, we can solve for the value of t equal to y over 3. Ang ibig sabihin itong t which is equal to y over 3, it is the time that the particle will move a distance equal to y. Now if this equation, the value of t which is equal to y over 3 will be substituted in our equation 1, which was just found a while ago. Therefore, our equation becomes x minus 4 equal to t squared plus t minus 2. With t substituted, its value of y over 3, therefore our equation becomes x minus 4 equal to y over 3 squared plus y over 3 minus 2. Which when simplified, x minus 4 will be equal to y squared over 9 plus y over 3 minus 2. Where this can be simplified further by taking the least common denominator of 9 and then simplifying, our equation becomes 9x equal to y squared plus 3y plus 18, which is actually the same as the answer given in the problem. And so let us try to consider working on the second problem. And here is our second problem. In the second problem, it says that the telescoping rod shown in the figure, here is the figure, forces the pin P, here is the pin, to move along the fixed path of 9y equals x squared. So there is the path that this P is traveling equal to the equation 9y equal to x squared, where x and y are in inches. At any time t, the coordinate of P is given by the equation x is equal to t squared minus 5t. And from here, we are to determine the y component of the velocity and the acceleration of p at x equals 6 inches. So dito naman, ang ipinapahanap sa atin will be the y component of the velocity, or in other words, the v sub y. And the acceleration of p at x equals 6 inches. The y component of the acceleration, that's also a sub y. So again, puntahan natin muna yung given. So in the problem, we are given the equation of the curvilinear motion, which is given by this 9y equals x squared. So let us try to consider that as our given. Similarly, we are also given the coordinate of point t at any instant time t. And we are given here that the coordinate of point t is given as x equals t squared minus 5t. So let us now take that given x equals t squared minus 5t. And let us consider this as our second equation. So from here, nakikita natin na if we are going to consider analyzing the situation, and I would like to again take note of this some notation that may help us solve the problem. Sabi dito, it is very important to understand that the equation of the curvilinear motion will give all the relationship between the components of the displacement, the velocity, and the acceleration. Ang ibig sabihin nun, kapag meron daw tayong equation of the path na kung saan the particle is moving in a curvilinear motion, then the equation of that path will give us all the relationship between the acceleration, the velocity, and the displacement along the two mutually perpendicular axes, either the x and the y. At yan yung gagamitin natin dito sa ating analysis. Kaya kung pupuntahan natin ngayon yung ating equation 1, which is our equation of the curvilinear motion, diba? And we will take the derivative of this. Okay? So, kunin natin yung derivative ng equation ito, that is 9y equal to x squared. So, when we take the derivative of that with respect to time t, therefore, we take the derivative with respect to t of 9y being equal to the derivative of x squared with respect to time t. And so, if we're going to take the derivative, the left-hand side would be equal to 9 multiplied by dy over dt, while the right-hand side would be equal to 2x multiplied by dx over dt. Ngayon, kung pag-aaralan natin, itong dy over dt, di ba, ay equal sa y component of the velocity. Samantalang ito namang dx over dt ay yun naman yung x component of the velocity. Kaya itong equation na na-produce natin after taking the derivative of the equation of the curvilinear motion with respect to time t can be reduced into equation such that we have 9 multiplied by v sub y shall be equal to 2x multiplied by v sub x. And let us call that this will be our equation 3. Now, if taking the derivative of equation 2, 1, the equation of the coordinate of p, expressed in terms of x, with respect to time t, therefore we will have here the derivative with respect to time t of x equal to t squared minus 5t. And so from here, we will be taking the derivative. The left-hand side of the equation would have a derivative equal to dx over dt, while the right-hand side of the equation would be equal to 2t minus 5. But again, itong ating dx over dt ay the same as v sub x, the x component of the velocity. So you can say therefore that the x component of the velocity is equal to 2t minus 5. And this may be considered to be our next equation, and we call this as our equation 4. And then afterwards, natin mula dito sa equation na x, which is equal to t squared minus 5t. Ito pa rin yung equation ito, yung ating equation ng coordinate of the force p. Now, if this will be substituted with the value of x equal to 6, therefore our equation becomes 6 equal to t squared minus 5t. And so from here, we can solve the value of t by simplifying first, that is t squared minus 5t minus 6 equal to 0, which can be solved by factoring. So that when we factor out, we will have the factors as a minus 6, a multiplied by t plus 1 equal to 0. And so we shall have here two values of t. One value of t will be our t sub 1 equal to 6. The other value will be t sub 2 equal to negative 1. This value of negative 1 may be considered as an absurd value. So we consider this as an absurd value. Ang ibig sabihin nito, the value that satisfies the equation but not the condition of the problem, because there is no such time as negative 1. But this will satisfy the given equation, and therefore we consider this as an absurd value. Again, we say it as a value that satisfies the equation but not the condition of the problem. Okay? So the value therefore of t will be equal to 6. So that when 6 will be substituted in equation 4, in this equation that we just have formulated a while ago, which is equal to v sub x equal to 2t minus 5. Therefore, we can solve for v sub x here. So, ano ngayon masusolve natin? So, we shall have here v sub x equal to 2t minus 5. And so, when x equals 6, so we can substitute that. 2 times 6 minus 5 will give us a value of the velocity in terms of inches per second that is equal to 7. Therefore, the x component of the velocity is equal to 7 inches per second. Then, after that, what shall we do next? So, kung isa-substitute natin ngayon, itong na-solve natin value of the x component of the velocity, which is equal to 7, and the given value of x, which is equal to 6, in this equation that I have formulated, showing the relation between v sub x, v sub y, and that of x. So, from here, masosolve natin ngayon yung y component of the velocity. So that 9 multiplied by v sub y equal to 2x multiplied by v sub x. Therefore, substituting v sub x and x, so you have 9 v sub y shall be equal to 2 times 6 multiplied by 7. And then from here, we shall have the y component of the velocity equal to 9.33 inches per second. Then after solving for the y component of the velocity, what shall we do next? So from here, if we will be taking the derivatives of equation 4, itong equation 4 na tinutukoy ko dito, ano? So if we will be taking the derivative of that equation with respect to time t, then from here, we can solve the x component of the acceleration. Right? So kunin natin, ano? So let us now take the derivative with respect to time t of v sub x equal to 2t minus 5. The left-hand side of this equation would have a derivative equal to dvx over dt, while the right-hand side would have a derivative equal to 2. But this dvx over dt is actually the x component of the acceleration, which when substituted will give us the x component of the acceleration equal to 2 inches per second squared. Now after we have computed for v sub x, v sub y, and that of a sub x, now we will be now solving for the y component of the acceleration. And how are we going to do it? Now let us now try to consider taking the derivative of the third equation with respect to time t. So in order for us to solve for the acceleration of the particle in the y direction. Where is this equation number 3? Our equation number 3 is equal to 9 v sub y equal to 2x v sub x. So that when this will be differentiated with respect to time t, the left hand side would be equal to 9 multiplied by dvy over dt, while the right hand side would be equal to 2 times x multiplied by dvx over dt plus vx multiplied by dx over dt. But then again, alam naman natin na itong dvy over dt is our y component of the acceleration, as well as dvx over at is our x component, and dx over dt is our x component of the velocity. And so when we simplify, you would have here 9a sub y equal to 2x a sub x plus vx or vx squared. So this can be simplified when substituted with the value. We have our x equal to 6 our Ax equal to 2 and our Vx equal to 7. So that from here, we can substitute the value and compute for the y component of the acceleration, which when simplified will give us a value of 13.56 inches per second square. And so that is our second problem. Okay, so let's now move to the next problem. So the next problem natin is given here, such that, sabi dito, a particle is constrained to move upward to the right along the path 2y squared equal to x cubed plus 26. Kung saan x and y are in inches. The x-coordinate of the particle at any time t is given at t squared minus t plus 4. So from here, we are required to determine the y components of the velocity and acceleration at x equals. So itong problem na ito ay gaya ng naunang problem, ano? Kaya ko lang pinakitang muli para at least ma-refresh, okay, ma-recall natin kung paano ito isosolve, ano? Sabi ko nga, okay, kunin natin muna yung given, kunin natin yung equation of the curvilinear motion. So we have here 2y squared equal to x cubed plus 26. So you have here. And then we also consider the coordinate of the particle at any time t, which is given in terms of x equal to t squared minus t plus 4, and so you have here. And let us call this as our equation 2. So from here, pwede tayo mag-start with equation 2 para makita na agad natin yung ating value of the time t. Ano? So kunin natin yung t when the x is equal to 6. So we're given the equation that x is equal to t squared minus t plus 4. So when we substitute the value of x equal to 6, therefore our equation becomes 6 equal to t squared minus t plus 4. That this can be simplified to have t squared minus t minus 2 equal to 0. And this equation can be solved by factoring, so that the factors will be t minus 2 and t plus 1 being equal to 0. So that we shall have here two values of t. The first value will be t sub 1 equal to 2, and the other value will be t sub 2 equal to negative 1. And again, as I have explained earlier, this t sub 2 is equal to negative 1 will be considered as an absurd value. Absurd because this satisfies the given equation but not the condition of the problem. Okay? So makatwid, we'll be using t equals to 2. Diba? So makukumpit natin ngayon itong ating equation. So puntahan natin ngayon itong ating equation 2. Okay? Balikan natin equation 2 by differentiating it with respect to time t. Diba? Ang purpose natin dito, makuha naman natin yung x component of the velocity. Because if we will be differentiating it, we shall have here the derivative with respect to time t of x equal to t squared minus t plus 4, na kung saan itong left hand side would have a derivative equal to dx over dt, and the right hand side would have a derivative equal to 2t minus 1. But this dx over dt is actually equal to vx. Hence, we say that vx is equal to 2t minus 1. That if the value of t which was earlier established will be substituted here, okay, masosolve natin ngayon yung ating x component of the velocity. Diba? And that is equal to 3 feet per second. Now, if we're going to differentiate equation 3 with respect to time t, one is equation, then we shall be getting the x component of the acceleration. So that the equation 3, which is equal to v sub x equal to 2t minus 1, if this will be differentiated with respect to t, therefore we'll have the derivative with respect to time t of the equation. The left hand side of this derivative will be the derivative with respect to t of your vx, and the right hand side will be equal to t. But this dvx over dt is actually equal to the x component of the acceleration. Hence, we say that the x component of the acceleration is equal to 2. That is 2 inches per second squared. Now, what shall we do next? Now, if we're going to solve for the value of y from equation 1, kasi in equation 1 we are already given x, and we can solve for y here. So that we substitute the value of x equal to 6 in the equation, that is equal to 2y squared equal to x cubed plus 26. And so when we substitute the value of x of 6, you will have here 2y squared equal to 6 cubed plus 26, and that our value of y will be equal to 11. Now after you have solved for the value of y, okay, the value of v sub x, and so we can now differentiate the equation 1. Itong equation 1 natin, ano? Ang purpose naman natin dito ay ma-establish naman natin ito yung y component of the velocity. So that if this will be differentiated with respect to time t, therefore, here's our equation, 2y squared equal to x cubed plus 26. That if this will be differentiated with respect to time t, therefore, the left-hand side would be equal to a 4y multiplied by dy over dt. Na kung saan yung right hand side naman will be equal to, okay, the first term would have a derivative equal to 3x squared multiplied by dx over dt, okay, plus, okay, the derivative of constant will be equal to 0. But again, yung dy over dt natin is b sub y, at itong ating dx over dt is our b sub x, which can be simplified to be, okay, 4y multiplied by b sub y is equal to 3x squared multiplied by b sub x. And so from here, because we know already the value of y, we are given the value of x, and we just have computed our v sub x. So from here, we can compute for the y component of the velocity. We will be substituting, okay, v sub x equal to 3 is 1, okay, the value of x which is 6 that's given, and the value of y which is 11 is given, is substituted. So from here, masosolve natin ngayon yung ating v sub y. So that if we will be substituting our values, okay, the value becomes 4 multiplied by 11 multiplied by v sub y equal to 3 multiplied by 6 squared, okay, multiplied by 3, so that our v sub y is equal to 7.36 inch per second, as what is, okay, shown here as our answer. Now after that, what shall we do? If we're going to differentiate equation 4, itong equation 4 na nakuha natin, di ba? Okay, anong purpose natin dito? May establish naman natin dito yung acceleration. Okay, both, okay, the acceleration of the y component of the acceleration. Kasi may establish natin dito, ano? Kaya we will be differentiating it with respect to time t. So we shall have the left hand side to be a 4y multiplied by dvy over dt plus by multiplied by 4 dy over dt. Yun yung equation or derivative of the product, that is u dv plus v du. Shall be equal to the same formula. Okay, u is 3x squared, okay, the derivative of vx is dvx over dt, plus vx multiplied by the derivative of 3x squared, which is equal to 6x dx over dt. Again, iulitin natin, ano? Yung ating dvy is equal to a sub y, yung dvx natin is equal to a sub x, at yung dy over dt is equal to v sub y, okay? Dx over dt is equal to v sub x, ano? So kapag sinabstitute natin yan, we shall have 4y, okay, multiplied by ay plus by multiplied by 4by, this one is by, ano? Shall be equal to 3x squared multiplied by ax, okay, plus vx multiplied by 6 multiplied by vx also. So vx and vx will just be equal to vx squared. Kapag simplify natin yan, I have 4by squared equal to 3x squared multiplied by x plus 6x multiplied by vx squared. Okay, and so let us now consider this as our last equation. So from here, kung sasubstitute natin yung lahat ng na-compute nating value, ano ba yun? Okay, yung y natin equal to 11, yung ating v sub y which is just computed at 7.36, yung ating ax which is equal to 2, our vx which is equal to 3, okay, therefore our equation becomes 4 times 11 multiplied by a sub y, dito yun, ano? Plus 4 multiplied by 7.36 representing b sub y equal to 3 times 6x, 6 squared, okay, plus multiplied by 2 plus 6 times 6 times 3 squared. And so from here you have one unknown, okay, which is our a sub y, and that a sub y, okay, when substituted and when computed will be equal to 7.35 inch per second squared. And so guys, yan yung ating sample problem na ipinakita ko about the curvilinear motion. Sana sa pamamagitan ng mga sample problem na yan ay mas lalo nating naintindihan ano kung paano natin sosolvein ang mga problems that will deal with curvilinear motion. Okay, sana guys, patuloy nyo akong subaybayan by subscribing to this channel, and if you have friends whom do you think will be needing this kind of lectures, share it to them so that they will also be notified and informed of this channel. Once again, thank you very much for watching.